There is a structure built from clay, brick, and riverstone that heated a house, cooked every meal, baked all the bread, dried the laundry, and put the entire family to sleep at night. On top of it, it weighs 2 tons. It takes up a quarter of the room. And once you light a single fire for 90 minutes in the morning, it stays warm for 24 hours. Warm enough to sleep on through a Russian winter that drops to 40 below. It burns 90% less wood than an open hearth. It produces almost no smoke. In parts of rural Russia, Ukraine, and Belarus, families still use the exact same design their great-great-great-grandparents built in the 1500s. The materials cost $15 if you source them locally, under $200 if you buy everything new. The average American household will spend just under $1,000 heating their home this winter alone. That is the NEADA estimate for the 2025 to 2026 season. A family in 15th century Novgorod heated, cooked, bathed, and slept for the price of gathering firewood from the forest. You have never seen this in a single American home builder catalog. That is not an accident. The answer starts about 800 years ago in the birch forests and frozen riverbanks of medieval Russia. The earliest archaeological evidence comes from Novgorod, where excavations have uncovered primitive masonry stoves in residential layers dating to the 9th and 10th centuries. These were not the refined structures you will see later. They were squat platforms of stone and clay, built without chimneys, positioned in the back corners of log cabins called izbas. The smoke had nowhere to go except out the door or through a small vent cut beneath the ceiling. Russians called this heating method po chornomu, meaning in the black, because every surface inside the house, the walls, the ceiling, the rafters, was coated in a permanent layer of soot. But the principle was already there. You burn hot, you burn fast, you trap the heat in mass, and you let the mass do the work for the next 12 to 24 hours. By the 15th century, the design had matured into something extraordinary, the Russian Pechka, a masonry stove so large it occupied 1/4 to 1/3 of the entire house, walls 25 to 40 centimeters thick, a labyrinth of internal channels that forced hot exhaust gases to wind through passage after passage, surrendering their heat into the surrounding brick before reaching the chimney. To your eye, it looks like a massive brick box with a mouth. At the thermodynamic level, it is a 2-ton battery, a thermal capacitor that charges in 90 minutes of intense fire and discharges slowly, evenly, over an entire day and night. And here's the part that makes this design unlike anything in a modern HVAC catalog. It was not just a heater. The firebox doubled as an oven. You loaded cast iron pots using a long forked tool called an ukvat. You baked bread on the firebox floor using a wooden paddle. The cooking process was not frying or boiling. It was languishing, holding food at a steady declining temperature for hours. Russian cooks say the flavor of bread, porridge, and mushrooms prepared in a pechka cannot be replicated on any modern range. On top of the stove sat a flat brick platform called the ledzhanka. This was the sleeping surface. In winter, with regular firing, the ledzhanka maintained a temperature between 25 and 30 degrees Celsius, roughly 77 to 86 Fahrenheit, warm enough to sleep comfortably through a night that hits -30 outside. The physics do not negotiate. Mass absorbs heat. Mass releases heat. The heavier the stove, the longer the cycle. A 2-ton brick structure does not cool down in 2 hours. It cannot. That is thermodynamics, not opinion. The stove makers, called pechniki, were among the most respected tradesmen in Russian society. A well-built pechka lasted 80 to 100 years. A poorly built one smoked, cracked, baked unevenly, and could burn the house down. The Russians had a saying, "To dance from the stove," meaning start from the beginning, because when you built a new house, the very first thing you designed was the stove. Everything else, the walls, the roof, the furniture, came after. That is how central this object was. It was not an appliance, it was the house. Now here's where the numbers get uncomfortable. The NEADA, the National Energy Assistance Directors Association, estimates that the average American household will spend $995 on heating alone from November through March this winter. For homes heated by electricity, that number climbs to $1,223. For heating oil and propane, $1,500 to $1,600. Over a 30-year mortgage, a family in the Northeast will spend between $36,000 and $48,000 just keeping the inside of their house above 55 degrees. The United States HVAC industry generates over $156 billion a year. $156 billion. That is not a typo. That is contractors, equipment manufacturers, service calls, maintenance contracts, and replacement parts for systems designed to be replaced every 15 to 20 years. A masonry stove built from locally sourced clay and salvaged brick heats the same house on 1 to 2 cords of firewood per season. One cord costs about $200 delivered, zero if you have trees. So why does every house in America come standard with a forced air furnace, a gas line, and a maintenance contract? Why has the masonry stove, a design proven across an entire continent for 8 centuries, never appeared in a single mainstream American new construction plan? Why does a $12,000 masonry heater kit sell as a luxury item when the exact same thermodynamic principle can be built from a barrel and some clay for under $200? You already know the answer. A stove that lasts 80 years, uses almost no fuel, replaces your furnace, your oven, and your bed, and requires no service contract, is the worst possible business model for an industry that depends on you paying every single month. That is not a coincidence. And here's where it gets interesting. You are not going to build a 2-ton medieval Russian Pechka in your living room. That is not what this tutorial is about. What you are going to build is a simplified masonry thermal mass heater based on the exact same principle. A brick core with internal channels that captures heat from a short, hot fire and releases it over 12 to 24 hours. No moving parts, no electricity, no monthly bill. Here is your shopping list. Fire brick. You need between 150 and 200 fire bricks for the core. At Home Depot or Lowe's, these run about $1.25 each. That is $187 to $250 new. But here is the move. Call local masonry contractors. They overorder for every job. Most have pallets of leftover fire bricks sitting in their yard that they will sell for 50 cents each or give away for free. Check Craigslist, Facebook Marketplace, or drive past any commercial demolition site. Used fire brick works perfectly. Common clay brick. You need roughly 200 to 300 for the outer shell. These are 25 to 40 cents each new. Again, salvage is your friend. Old chimneys, demolished buildings, landscaping supply yards. Total cost new, about $75 to $120. Salvaged, often free. Refractory mortar. 2 buckets at about $50 each. This is the mortar rated for high heat. Do not substitute regular mortar in the firebox. It will crack and fail within weeks. Rutland and Quikrete both make refractory mortar available at any hardware store. A firebox door. This is the most expensive single component. A proper cast iron masonry heater door runs $500 to $1,500 from specialty suppliers like Maine Wood Heat or Northstone Heat. But here is the workaround. A traditional cast iron clean-out door 15 inches by 15 inches costs between $35 and $90. It does the job. You lose the glass window, but you gain $800. Clean-out doors, 2 small ones, 5 by 5 inches, for ash removal and flue access, about $15 to $20 each. A damper for your flue, about $20 to $30. Clay flue liner tiles, 15 sections at roughly $10 each, $150. High temperature silicone sealant, 1 tube, about $12. Ceramic fiber gasket material, 1 roll, about $20 to $30. Total cost if you buy everything new, no scavenging. $700 to $900 for a basic masonry heater that will outlast every furnace on the market. Total cost if you scavenge brick and use a clean-out door instead of a glass door. $80 to $150. Total cost if you do what the Russian peasants did, source clay from your land, gather fieldstone, and build the shell from cob. $15 to $40 for just the mortar and gasket material. Now, the build. Step 1. Foundation. A masonry heater weighs between 2,000 and 4,000 pounds when complete. You need a reinforced concrete pad at least 4 inches thick. If you are building on a slab, you are fine. If you are on a wood floor, you need to go down to the footer. Do not skip this. 2 tons of brick on a wood joist floor will end in structural failure. Step 2. Lay out the footprint. A basic contraflow heater measures roughly 3 feet wide by 2 feet deep by 6 to 7 feet tall. Mark your footprint on the pad. Dry stack your first course of common brick to verify dimensions before you commit with mortar. Step 3. Build the outer shell base. lay 3 courses of common clay brick with standard masonry mortar. This is the non-heated base that supports everything above. Step 4. Build the firebox. Switch to fire brick and refractory mortar. The firebox is the combustion chamber. Interior dimensions should be roughly 13 to 18 inches wide by 18 inches deep. Line the floor, back wall, and side walls with fire brick laid on edge, known as shiners. Leave space for the door frame at the front. Step 5. Build the channel system. This is where the Pechka principle lives. Above the firebox, the hot gases must travel through a series of vertical channels before reaching the chimney. A basic contraflow design sends gases up over a baffle, down the back, under the firebox, and into the chimney at floor level. The gases surrender heat at every turn. The more surface area contact between hot gas and brick, the more heat stays in your house instead of going up your chimney. For a first build, do not get fancy. 2 vertical channels with a single baffle cap is a proven, simple layout. The Masonry Heater Association, the MHA, publishes free plans for contraflow designs. Download them. Step 6. Install cleanouts and damper. Place your cleanout doors at the bottom of each downdraft channel for ash removal. Install the flue damper at the chimney transition point. When the fire burns down to coals, you close this damper to trap the remaining heat inside the mass. This is the move that extends your heat cycle from 12 hours to 24. Step 7. Build the chimney transition. Transition from fire brick to clay flue liner. The flue liner carries exhaust through the ceiling and roof. If you do not want to build a full masonry chimney through the roof, switch to a Class A insulated metal chimney pipe after you clear the ceiling. This saves significant labor and weight. Step 8. Cure the heater. This is the part that ruins 90% of first builds. Do not light a full fire in a freshly built masonry heater. The moisture trapped in the mortar and brick will flash to steam and crack your entire structure. Start with small paper fires, just crumpled newspaper. Do this for 3 to 5 days. Gradually increase to small kindling fires over the next week. After 2 weeks of progressive curing, you can light your first real fire. When you do light that first real fire, use dry, well-seasoned hardwood. Split it to 3 to 4 inch pieces. Stack it in a crisscross pattern. Light it from the top down, not the bottom. Top-down lighting produces less smoke during startup and brings the firebox to peak temperature faster. One more critical detail. A masonry heater fire is not a wood stove fire. You do not keep it burning all day. You burn hot and fast for 60 to 90 minutes. Let it burn down completely. Close the damper, walk away. The brick does the rest for the next 12 to 24 hours. For the advanced version, you can add a cooking surface on top of the heater by capping the firebox with a cast iron plate. You can add a heated bench, called a lezjanka in Russian or Ofenbank in German, by extending a horizontal flue channel into a masonry bench beside the stove. You can build a bake oven chamber above the firebox for bread. For cold climates where you need more heat output, do not build a bigger firebox. Build more channel surface area. Add a 3rd or 4th downdraft channel. The firebox size stays the same. The thermal mass increases. That is the entire principle. Now here is what this design will actually deliver and where it will not. Mother Earth News documented a DIY Russian-style masonry heater that once fired for 1 to 2 hours in the morning, stayed hot for about 24 hours and warm for 48. The builder reported heating a full-sized house through a northern winter on roughly 1 to 2 cords of wood per year. Masonry heater manufacturers rate combustion efficiency at 85 to 95%. That means 85 to 95% of the energy in the wood becomes heat in your home, not smoke up the chimney. A modern EPA-certified cast iron wood stove is rated 60 to 75%. A traditional open fireplace captures roughly 5 to 10%. The difference is not marginal. It is generational. The Lezjanka sleeping platform maintains a surface temperature of 25 to 30 degrees Celsius through the night. That is documented across multiple sources and consistent with the thermal properties of brick at this mass and thickness. But here is where the boundary conditions matter, because this channel always gives you the full picture. A masonry heater has high thermal inertia. That means it is slow to respond. If you come home to a cold house and you need heat right now, a masonry heater will not help for 2 to 3 hours. It is a planning tool, not an emergency tool. You fire it in the morning and it keeps you warm through the night. If you forget to fire it, you are cold until the next cycle catches up. This design works best in well-insulated homes. In a drafty, poorly sealed structure, the slow radiant heat output will not keep up with heat loss. Insulate first. Seal your windows and doors. Then the masonry heater becomes extraordinary. And the obvious one, This involves fire, masonry, and significant structural weight. Check your local building codes before you build anything involving combustion. Some jurisdictions require a permit and inspection for any solid fuel heating appliance. Some insurance companies want to see UL listing, which a DIY build will not have. Know your local rules. Build smart. 800 years ago, a family in medieval Novgorod, with no electricity, no engineering degree, no internet, and no hardware store, figured out that you could heat a log house through a winter that drops to 40 below by burning one fire a day in a stack of bricks. They cooked on it, they baked bread inside it, they dried their clothes on it, they bathed in it, they gave birth on it, they healed the sick on top of it. And at the end of the day, the grandfather climbed up on the Lezhanka, the warmest spot in the house, and slept through the night on 2 tons of slowly cooling stone. He passed this knowledge to his son. His son passed it to his grandson. For 40 generations, through invasions, famines, revolutions, and 2 world wars, the Pechka survived. It was the first thing built in every new house and the last thing standing when the house fell down. Somewhere in the middle of the 20th century, when the gas pipeline reached the village and the electric grid reached the farm, the Pechka stopped being necessary. And knowledge that is not necessary stops being taught, not because it fails, but because it is no longer profitable to remember. Now you have it back. You know that a single fire in the right structure can heat a house for 24 hours. You know that the design is older than the Renaissance. You know that the materials cost less than a month of your utility bill. And you know what a $156 billion industry depends on you not knowing. Here's the part that stays with me. The most sacred spot in a Russian peasant home was not the bed. It was not the table. It was the top of the stove, the warmest place in the coldest country on earth. And they built it themselves, from dirt beneath their feet. If this changes the way you think about heating your home, send it to one person, not everyone. Just the one person you know who is tired of writing a check to their utility company every month. If this is the kind of knowledge you want to keep seeing, subscribe. This is not a feed, this is a mission. Knowledge like this does not disappear on its own. It gets buried. This channel digs it back up. Thanks for watching. I will see you in the next one.